get that going. I'm going to put the derivative with respect to x of cosine x. If you answer this question without looking at your paper, I'm going to be like, what? The answer is no idea. What? This is not a polynomial. So we've been talking for a while. You now know how to find the derivative of every polynomial in the universe. Yay! That's not a polynomial. And if you ask the question, why do we take trigonometry or take trigonometry before we take calculus? That's the answer right there. Hey, I want to find the derivative of cosine. What's cosine? So we are going to, because we can't use our newfangled polynomial thing, we're going to have to instead go to the land of formal definition of a derivative. So it hasn't gone away. We know it works. It works for everything. So we're going to have to go formal definition. Talk to me about formal definition.
Isn't it?
Well, it's a limit.
Oh, limit of delta
X approaches 0.
And then it's f in parentheses. Oh.
I'm just going right to it, man. Don't look at paper.
Sine of, or is it cosine? Yeah,
Oh, you're right. It's cosine. I'm not doing the wrong one already.
It's cosine of delta x.
The x plus delta x, right?
Yeah.
Minus
Cosine x.
cosine x
Divided by delta.
all over delta x. Now, at this point, I need to pause. You guys lost the last 3 minutes, the last 3 months of your trigonometry. This should look familiar. I'm a little frightened maybe it doesn't. Does it look familiar?
Funny story. The textbook video. Yeah.
Sorry, what?
Your words don't matter.
I'm recording whatever you just said. All right. It was what?
It was written by some guy.
Oh, you mean the trig book?
Yeah.
Yeah, trig book is terrible. Trig book is...
Oh, well, that was my...
Okay, good, yeah. No, you make fun of the trig. If he watches this video, I want him to know his book is terrible.
Blitzer sucks.
Okay, yeah, there we go. Blitzer sucks. Okay, so we need to go forward. You should know the following. You cannot use a distributive property on that. Do you know that? Like if it was cosine 45 degrees plus 45 degrees, that's not the same thing as cosine 45 degrees plus cosine 45 degrees, is it? Because cosine of 90 degrees would be 0, and cosine of this would be root 2 over 2 plus root 2 over 2, and that's definitely not true. Right? So you can't use a distributive property on there because it's not multiplication, it's trigonometry. So, with that in mind, there is an identity you should have been familiar with. You should have seen it at least, I hope. I don't know, maybe you never saw it. I promised I was going to talk to Manning about this. I did not get a chance to talk to him about it. And that is, when you have two angles added up, there's something called the summative property. There's a way you can prove this. I don't want to prove it to you because that should have happened last year. Okay? But here's the deal. You can rewrite an addition as cosine of x, cosine of delta x, minus sine x, sine delta x. Now, you should have seen that. I don't think it got pounded into you because you were already in the land of virtual learning back then, at that point. But did you see that at least? You don't have to have it memorized. Swear to you don't have to memorize it. You just have to know that, oh, yeah, that's a legit thing. If you can just say that, I can keep going. All right, I got enough bobbing heads. I'm going to go with it. Okay, so now I just have to finish this thing up and figure out what it is. So knowing as I know, you're looking at your paper, you're a cheater. We're going to prove this. It's all there. You can look at it later, see if I did it right. I might have done it wrong. You never know. I was going to call on you in just a second.
I was looking at the sine one.
Okay, well, let's look at the cosine one. Okay, so I need to match this. If I plug in 0, I get 1 times 1 minus 0 times 0 minus 1. That's 0. Bottom it's 0. Oh, that's right. We're trying to find a derivative. It's always going to be 0 over 0. I just wasted some time. Next step, factoring. Does anything come out of everything on the top, Mr. Finn? Nothing comes out of everything on the top, so we can't do that. Now we use our special tricks. This one clearly is a special tricks problem. I got cosines and I got sines. Now, how am I going to gather them? Well, I should put the cosines together at least, right? at least tried to do something with those. So limit as delta x approaches 0 of cosine x cosine delta x minus cosine x all over delta x. And I'm going to do a minus sine x sine delta x over delta x. Now here's some good news. We know what to do with this, right? I know that can go away and become a 1. What about this? Well, can I at least factor out a cosine x? Is that okay with you, sir?
Yeah.
All right, let's do it. Limit as delta x approaches 0 of cosine x cosine delta x minus 1 over delta x. That should look vaguely familiar. Sine x sine delta x over delta x. With me so far? Now, that's not 1. What is this?
0.
That's 0. So that goes away. This is 1, right?
Yeah.
So when I go to take the limit, I've run out of delta x's. They're all gone. So now it's going to be the derivative with respect to x of cosine x is in fact
Negative sine x.
negative sine x. Yeah.
Somehow more convoluted.
Sorry, what?
It's mildly more convoluted on the paper though.
Mildly more convoluted paper? Well, that's a miracle. I tried to do that as convoluted as I possibly can. Okay, so that's one thing. Now, let's just talk about this for a moment and see if this makes sense. Mr. Bond, you're going to be our... Actually, who was your graphing specialist last year in trigonometry for graphing trig functions? Manning was? He did all of it?
The calculator?
Flynn!
Yeah.
Flynn! Do you know what a sine curve looks like? What's a sine curve look like? Right? And at pi it's here, 2 pi it's here, pi over 2, negative pi over 2. Oh, sorry, 3 pi over 2. With me so far? Okay. And this is 0. And then cosine curve looks like what? Starts at 1. Okay. Goes like this, right? Where this is pi over 2, this is pi, this is 3 pi over 2, and this is 2 pi right here, right? All right, so if I was going to graph the derivative of this, just ballparking it for right now. What's the slope right here? 0. It's top of my curve, 0. And then it starts going negative, right? At this point here, though, it's its maximum negative, isn't it? Because it's going to start getting flatter now, right? Does that make sense? So I should have a maximum amount of negative slope right about here. And then what happens with my slope here? 0, so I'm back up to 0. And then right about here, I should have my maximum positive slope, right? Before I switch and start mellowing out again, right? So that's my maximum. And then what's my slope? What's my slope right here? 0. Well, look. It's sort of like a sine curve, except it's upside down. So what would the derivative be? Negative sine x. And that's where it comes from. Now, all of this said, you never have to do that again. You have to memorize the derivative of cosine is negative sine. That's what you have to memorize. Agreed? And there's a proof down there which we could go through. And you can reason it out just like we just did. If you want to do that, you're welcome to do so. But the derivative of sine x is going to be positive cosine x. Those are just two things to memorize. Straight up, you're not going to drive this every time. You're not going to use the formal definition. Why would you do that, right? Now I've got it. I'm never going to go back there again. Good? Okay. With that in mind, turning the page. Everybody try problem number 19 on the back of this page. Ooh, you do it. Turn it the other way. All right. You better off that way, yeah. Is that good? What's that? A rowing machine. There's no longer time when I get home to exercise. That's how my life is now. COVID-19 is not going to kill me because of the disease. It's going to kill me because I don't get enough exercise and fall down and die from that.
You hit, it's like in your own degree.
Yeah, off period. I got scratches on the floor. I'm dragging this thing all over the place. I run as fast as I can for a while, and then bad things happen. Probably. Yeah, too much information about Mr. Reddick. Get to work. Here we go. You ready? Y equals. Hey, there's a number multiplied out in front. What do we do with numbers that are multiplied out in front?
No.
Sorry, what?
Put it there.
That's only if you have a power. We don't have a power here. What do these numbers normally say there? Like if I got 2x to the 7th power, what happens to this 2? Yeah, whatever. It just sits there, right? It's ignore it. It's like having a vacation. It's happy to be where it is. So what's going to happen to this? Just going to sit there. What's the derivative of sine?
What?
Did I get that wrong? Derivative of sine is positive cosine, right? Okay, and the derivative of cosine is negative sine, so negative sine. So the answer would be y prime, this should be y prime already, pi over 2 cosine of theta plus sine of theta. Woo! Doing calculus with trigonometry, no less. Now we're cooking. All right, start blowing through the rest of these. I'll write some answers up on the board. Oopa. Oh, that's G prime.
I'll be right back.
I'll be back. But you didn't take the hall pass with him. That was ominous. Da, 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 23. You want me to do 22? All right. So what's the derivative of 5? Goes away, right? Now it's not multiplied. That's why we have to take the derivative of this, and it goes away. Sine of, isn't it positive cosine? This is the time I got this wrong. Sine's cosine, right?
Yeah.
Am I smoking something?
No, you're right. Yeah, but
Okay, you guys gotta stop doing that to me. Eventually I'll start believing you. All right, I'm going to rewrite this because I don't know how to do it this way. Suddenly I know how to do it. Yeah, you know, you guys got me so frazzled I'm starting to think wrong. I think that's right still.
Yeah.
Woo! It's actually got me thinking backwards. Good job. Usually it doesn't happen until we get to doing them backwards, which is integrals.